Good morning. I'm Pat Ryan with the Public Affairs Office at NASA's Johnson Space Center, and we're happy to join you. With me today is Angela Bauer. She is the lead of the Facilities Operation Maintenance Group, which is part of the Mission Operations Directorate, and they are the folks who are responsible for taking care of everything in these buildings that is there to help support the people who are supporting the folks who are on orbit, which is sort of an inarticulate way of describing what you do. But tell us how you got to that point. Tell me about what kind of background does set somebody up to be in charge of maintaining this kind of environment?
Well, I actually graduated with a degree in mechanical engineering, and after I graduated, I went to work for a couple of years in the petrochemical industry, but I was always so attracted to NASA and always looking for a way to get here. And so I did finally find a way to come and work for NASA, and I was lucky enough to be a Shuttle electrical power systems flight controller. So we controlled all of the power systems on the shuttle. But then after a couple of years, I was given the opportunity to come over and manage a large project replacing workstations here in the control center. And I jumped at that opportunity, and I've been here ever since.
Sounds very exciting. We'll find out more about it, and I think we're ready to take your questions. So go ahead.
Okay, our first question says, how much pressure is it to work in mission control?
Angela, how much pressure?
Well, it really depends on the moment. Most of the time, working in mission control is something that you've been very well trained to do, and you sit at your console and you watch your data do very predictable things, and you do procedures that you've trained on extensively, and so it's all very easy. The pressure comes when something goes wrong, when something on board breaks, and all of a sudden you have to jump in and you have to fix it. And we train our flight controllers for that too. We do extensive training. We have a saying that we train like we fly, and we fly like we train. So we feel that our flight controllers are all very capable of handling all this, but it does make for some exciting times here in mission control.
Okay, the next one says, what is the average education of someone in mission control and an astronaut?
Okay, well, it's different for flight controllers in mission control and astronauts. Not that it has to be. To be a flight controller, all you have to have is a science degree, so that would be either science, engineering, or math. And most of our flight controllers have bachelor's degrees. We do have some who have masters, and we have some who have PhDs. It really depends on the person and the choice that they made in their schooling, but all that you're required to have is a bachelor's degree in science and engineering.
Most of the astronauts do have advanced degrees, though, master's degrees, and a lot of them doctorates as well. Even the pilot astronauts who are in charge of driving the spacecraft, if you will, a lot of them have advanced degrees in engineering as well.
Okay, the next one says, what is the additional training for someone working in mission control?
Well, when we bring our new flight controllers in, we actually have a set of classes that right now we're calling boot camp. It's been called different names over the years, where they spend several months going through intensive training on all of the different systems that are on the International Space Station. And then after they get through that, then they get put into a training flow where we have smaller trainers that are not in this building. They're over in another building where they can sit with just a couple of people and start to do troubleshooting on their systems. And then finally, after they've mastered some of those basics, then they come over here and we do integrated simulations where we have the entire flight control room participating. We have computer models that pretend that they are the space station so we can mimic things and conditions on the space station, and we have a whole group of instructors where their whole job, all they've been trained to do, is to teach our flight controllers how to do their job.
If our space shuttle program is not operating, how do we plan on getting astronauts to the ISS?
Well, we actually knew for quite a few years that the space station program was ending, or the space shuttle program was ending. And so we had a long, long time to plan for it. So what we do right now is that we have the Russians send up our astronauts in their Soyuz spacecraft. And so that's been well negotiated, and they change out their crew every 6 months.
How much oxygen do they know to bring and have on the ISS?
Well, since we've been doing spaceflight for a long time, we know how much oxygen a typical person needs in a day. And so I can say for Space Shuttle, we actually had to take all of our oxygen, and so we took it in big tanks. But for Space Station, they're up there for such a long time that we have many different ways of getting them oxygen. So we have some equipment on board that can turn water into oxygen. We have equipment that when activated, it's basically like a candle that has a chemical reaction and releases oxygen. And we also can send oxygen up in some of our resupply vehicles.
How long does it take to get to the ISS?
Well, that also depends on the vehicle. Technically, it doesn't take that long to get there. You know, coming back, it takes about 2 hours, but going there, it takes a lot longer. First of all, because we have to launch, so it takes you about 8 minutes to get to orbit, but then we have to catch up with the space station. You also have to make sure that your vehicle is correctly oriented, and you have to make sure that your crew has acclimated to space travel so that they're able to do the docking. So normally for us, it takes us between 3 and 4 days. The Europeans sometimes take a little bit longer, so it just depends on the flight control team and the astronauts and which country is operating the vehicle.
Do you see robotics as an important part of the future of space travel?
Yeah, robotics is very important. We can send robots to do things that we wouldn't want to send humans to do or that we don't have enough humans to do. So we already use many robots in space travel. We have a robotic arm on the space station. We also have Dexter, which is on the space station that can do tasks. And in addition to that, we also have things like our Mars rovers that are robots that we operate. So robotics is very important.
Discuss the funding for future spaceflight. Do you think it will be more commercialized?
Well, okay, that's two questions. Mm-hmm. First, for the funding, we are a government agency, and so our funding depends on whatever Congress has money to do and how they allocate it. So we only know our funding from year to year, and we always hope that they'll give us more, but we won't know. For commercialization, we are actively striving to increase the commercial participation in spaceflight.
In fact, we're using some of the money that we have in order to provide seed money for private companies that are currently working on developing both cargo ships to help supply the space station, and some of them are also working on future vehicles to bring crews to the space station and maybe to other destinations as well. So NASA is investing in that as a way to get people to orbit in the future too.
Could you describe the Orion multi-purpose vehicle?
Could I describe it? Well, we're getting away from having the space shuttle type of vehicle. The space shuttle, while it's really cool and very flexible and that it can go up and down many times, is also very, very expensive to maintain and operate. And so the Orion capsule is more like what we had back in the Apollo days. So it's a smaller capsule that is easier to launch, and it enters just like the Apollo capsule did.
Although it's bigger than the Apollo capsule, and
That's
it will
right.
be able to carry 4 or 6 astronauts, where the Apollo could only carry 3. And it's being designed to be able to go a lot farther away from Earth into the future, too.
Right.
Hold on just a second.
Are there any questions that you guys have that we haven't asked already? If you have a question, come on up and just stand over here. Please feel free. This is your chance to talk to Mission Control. This might be a once-in-a-lifetime thing, so please think if you have a question.
Is there any possibility of
Speak in the microphone.
Is there any possibility of getting to Mars soon? Or in the future?
Well, that depends on your definition of soon. I definitely think we'll get to Mars sometime in your lifetime. It's not going to be this decade. Right now, we have got plans for the Orion capsule to launch, and they're looking at going to an asteroid first, and then perhaps to Mars, probably somewhere out in 2030 would be the earliest.
Yeah. But I think it's definitely going to happen. There are a lot of people who are working on working out the issues with propulsion that are necessary in order to get a spaceship that far away. They're also working up on the issues that are required to be able to sustain a crew. I mean, we could shoot a rocket to Mars. We do it now, but we want to be able to have the crew members who are on board be able to be safe and to be healthy when they get there, because it's about a 6-month trip to get there, and then there's the amount of time that you would be there to do the work, to do the exploration, and then another 6 months to come back. So there are mechanical issues, and there are also human issues that still have to be worked out before we could do it with a relative degree of safety.
What kind of problems do you face normally when they're launching, if there are any?
Are there any problems in launching? Yes.
There are occasionally problems in
are.
launching. Right now, all of our launches are done by the Russians, and so they control all of that. So I can tell you a little bit about some of the problems that we would have during the space shuttle when we were in control of that launch. And actually, problems were very rare. We do so much testing that it's uncommon. Most likely, probably if we looked at what the most common failure would be, it would be that we lost a piece of telemetry. Not that something actually happened on board, but for some reason that transducer stopped working.
And by telemetry, we're talking about information, data that's coming down.
Right, a number that tells us how many volts a certain piece of equipment has or how fast a certain piece of equipment is rotating.
So since a rocket is basically a controlled explosion, is there any chance of using a nuclear blast to go into deep space in the future?
Well, we're always looking at advanced propulsion. I haven't heard anything about using a nuclear blast to get into space. Actually, most of our efforts right now are looking at using rockets that have less energy but end up spitting it out at a longer time so that you would be able to go a farther distance with less fuel.
There's a former NASA astronaut named Franklin Chang Diaz who is really in the lead in developing this kind of engine where you would carry enough fuel to be able to make just a little thrust that would push your vehicle along and on a regular basis. But because in orbit and out beyond Earth orbit, you don't have the resistance, you don't need very much push in order to get it going. And you continue to build up the momentum with every new impulse. And you can go a great distance in a relatively short period of time once you get started.
How do you choose the astronauts that go up to the space stations?
And that's really a question for the astronaut office. I know that they do a lot of screening on their astronauts when they pick them to be candidates in the first place, and then astronauts go through about 2 years of training once they get selected. So they go through 1 year where they do astronaut candidate training, which is kind of generic training, and then they do about another year of vehicle-specific and mission-specific training. And so I would imagine that their choice of who they're going to pick depends on how well those astronauts do in that training.
Do you ever think we'll officially live in space?
Personally, I do think that we will live in space. NASA is always trying to put ourselves at the front of the space technology. We're trying to do the new things that nobody else has done before. And as we figure out more and more ways to travel in space, then we end up giving that information over to other people, such as commercial partners, so that they can then use that information to make a commercial venture, a company that can then capitalize on that and make space travel accessible for all people. So I do believe that we'll get technology to the point that we can give it over to commercial partners and they can make space tourism a real option.
And in the meantime, there are people living in space right now. There are 6 people on board the International Space Station. 3 of them have been living there since late November. The other 3, actually today is the 100th day that the other 3 have been in space. There is one Russian cosmonaut who lived in space for over 430 days without coming back to the Earth. So we are living there now. We're not living there for as long as we will in the future, though.
Is there any possibility of going back to the moon?
Well, there's always a possibility of going back to the moon. When the president made the decision to refocus the constellation efforts, we decided that we were going to instead focus on going out to an asteroid and then to Mars. So we don't have any plans to send people to the moon right now. We're always looking at what kind of rovers and robotics we could do at the moon. And actually, one of the the activities that's operated out of this building is a program called Desert Rats, where we do a simulation of what it would be like on the moon. They go out to the desert in Arizona, and they test spacesuits and rovers to see how they work. So we're constantly striving for that.
And NASA has a pair of spacecraft orbiting the moon right now. The Grail mission just sent 2 spacecraft that are mapping moon. So we haven't sent people back just yet, but we are still going to the moon.
Okay. Are you looking into fusion reaction for energy?
Fusion reaction. Are we looking into that for energy?
Not that well.
I'm not sure. I don't know that NASA is. I mean,
Yeah.
there are people who are, but that seems to be still quite a bit a ways away.
I know in mission control we're not focusing on it right now.
No, it's not in one of your buildings here.
No.
When Apollo 13 claimed the moon for the USA, is it possible that we will be sharing the moon with other countries?
I think that's entirely possible. For us, the moon was our goal back in the 60s, and we achieved it. And I see no reason why other countries wouldn't want to have that same goal and achieve it just like we did.
Yeah. When Apollo 11 was the first mission to land on the moon, and they planted an American flag, but they didn't really claim it for America. And you're remembering Apollo 13. That was the mission that circled the moon, but they didn't actually land there.
Okay.
Yeah, go ahead.
How many missions have you helped get into space?
We had
135 space shuttle missions that flew.
Right, and then we also had all of the Apollo missions.
And all the Gemini and Mercury missions, as well as all of the launches to the International Space Station. The group that's on board right now is Expedition number 30. And there are crews who aren't even going to launch for another 2.5 years, who are already training for their flights.
Are there any other questions?
Come on, Gabby.
Do you remember how many space shuttle missions you worked? How many of those did you help put into space?
I didn't count.
A dozen or so, probably.
It was a dozen
in
or
those
so.
years.
And my last was STS-107.
Okay, good. What kind of problems, or not problems, like what kind of things do you have to do to prepare to go up into space?
You mean if you're an astronaut?
No, like for your mission control.
Well, okay, so we start our flight controllers out with generic training, where they do training on basic simulations and basic procedures that we go through. And then about 6 months out, we start with what we call flight-specific training, where we actually rehearse every single major activity that's going to happen on orbit. And so we probably have about 15 to 20 of those type of activities that involve the entire flight control team. And they increase in frequency as we get closer to the start of the increment.
How many rockets have blown up during the launch?
Well, okay, so if you're going to talk about manned space flight, I only know of one that's blown up, and that was Challenger. We had another accident with an Apollo rocket, but that didn't blow up. It was on the pad. And if you're talking about the other rockets that get sent up, most of those are handled by the Department of Defense or through another company, which is United Launch Alliance, which is a combination of Lockheed Martin and Boeing. And so I don't know how many they've had blow up, but they're the ones who do most of the actual rocket launches these days out of the Cape.
What is NASA's ultimate goal as far as space travel?
Well, NASA is always trying to explore, so our goal is to get as far away from this planet as possible and to do so in a safe manner. So we're constantly striving to do new science that lets us figure out exactly how people are going to be affected by long-term space travel, how equipment's going to be affected, more effective ways to do things so that we can get to farther places with less mass, less energy. So I think NASA long term is going to try and go as far as they can. Right now they've set their sights on Mars in 2030.
How does NASA work with Department of Defense?
You know, we actually have some Department of Defense folks who are on site with us. We used to do a lot more with them because back in the middle days of Shuttle, there were actual Department of Defense missions, and so we had one of the flight control rooms was actually locked down and was very secret because it had Department of Defense assets in it. These days, we do interface with them some, but most of our involvement is with either universities or commercial companies that have payloads.
But there are people from the several branches of the service who work here in a variety of places, not only astronauts,
Right.
but there are other people who are assigned by the Army or the Navy to come to NASA to work in flight control positions and in other places around here in Houston.
Do you have a question?
What's the furthest a robotic spacecraft has gotten away from the Earth?
It's left the solar system, haven't we?
Yeah.
Voyager. I'm not sure if that's the farthest we've gone, or the furthest, whichever is correct. But early robotic spacecraft that were launched back in the 60s have left our solar system.
What is your favorite part about working for NASA?
That's a hard question because honestly, I love everything. Probably my favorite thing to do here at NASA is to do events like this and take people on tours, because when you're doing your job, even though it's space, it tends to still be processing paperwork to get monitors replaced and workstations replaced and update code. And when you get an opportunity to do something like this or to bring people through mission control, it reminds you how cool it really is.
Yeah, working in this room is pretty cool. Getting to sit at one of these consoles and listen to all of these people talk about what's going on the space station and how we're making sure that we stay on the plan for what we want to do, or how we're going to try to resolve some issue that's come up, and being right here in the middle of it, that's pretty good.
Do you guys still send animals up into space?
You know, I think there have been some payloads recently that were sent up that did involve rats. I know when I was working as a shuttle flight controller, we had to account for the amount of oxygen the rats would consume. But we haven't sent primates up in many, many years. We did that in the beginning because we weren't sure what the effects would be of human spaceflight on humans, and so we wanted to be very cautious. But these days, the only animals that go up are going to be part of an experiment.
What happens when an astronaut gets sick up in space?
Well, we actually have a whole team down here called the flight surgeons who take care of astronaut health, and they carry a lot of medicine with them up in space, and we have a capability for them to do private medical conferences where they can call down and talk to or have a video teleconference with the flight surgeons to discuss whatever ailment that they have. Our astronauts are also trained in many of the standard medical procedures that you would expect from, say, an ambulance crew. So if something critical were to happen, then they have the capability of responding to it as long as it's something somewhat standard.
I heard somewhere that astronauts can swell up in space. How does that happen?
Well, in space, there's no gravity. So on the Earth, all of your fluids are pulled constantly towards your feet, and your body does account for that in some ways. I mean, by the end of the day, you are going to have more fluid at your feet than your head, but overall, it stays pretty constant. But when you're in space, there's no gravity, so the fluid just accumulates in your body, and it's not pulled down towards your feet. So they do tend to have puffier faces when they are in orbit, but it changes when they get back on the ground.
Is there any other questions that we have not asked yet?
I think you've asked some really good questions.
All right, wonderful. Dowell Middle School. This is Michael Harrigan from the Digital Learning Network. Did you want to say a final goodbye or thank you to Pat Ryan and Angela Bauer for all their great answers?
Thank you.
You're welcome. Goodbye. Hey, it was great to talk to you, McKinney, and we'll talk to you again soon.